when the user apply the power in a monostable mode here, the timer will let the user to set 500k trimmer to the middle range, and we set the 200k all the way to the clockwise here. Then this will create the pulse for the LED. Okay, here I should demonstrate here. How is it? Positive to the positive rail here, GND to the negative rail here. Okay, now when we rotate this 500k to the middle range, and we rotate the 20k to the full on clockwise mode here, and press up this, it will light up in a certain period. This is what we read as push button A here. This is the push button A here, and here is the push button B, which is for the reset. When you press the push button A and push button B reset, it will be interrupt here. Okay, and then it will straight away interrupt during the period when the LEDs light up here. And during this period on the pin 2, which is for the trigger point pin here, the multimeter on the pin 2, if let's say we put a multimeter here at the pin 2 and one to the ground here, we'll measure low voltage below 3 volt. Alright, and the timer will trigger 1/3 of the voltage. Let's say right now we got 9 volt battery here. At 1/3, then we got around 3 volt for the battery on the trigger point here. This is the pin 2, which acts as a trigger point here. When you press the button, you'll have one same length of the pulse unless we interrupt with this push button here. If we press this push button in the middle of the LED when it's light up during the period of time, it will interrupt, so it make it as a shorter time for the LED to light up, and then it fade out there. To demonstrate this, so I have got a positive rail and a negative rail here. When I turn this to the fully on the clockwise mode here, right, turn fully on the clockwise mode, the LED will be light up. Means 3 volt was supplied to the LED there. And let's say this trim port is back to the anti-clockwise mode here, and I press the LED will not light up because it's connected fully on the ground volt, so 0 volt is supplied to the pin 2 here, and therefore the LED will not emit the light there. And the pin 7 is set as the discharge pin was through the trimmer and the resistance here. You can know that here is the pin 7 here. Then it flow through the resistor and the trim there. Pin 7 here, which is connected to the trim port here. Then the trim port goes to the 10k resistor, which is here. Alright. It depends on the resistor, means the LED during the certain time of period light up, it depends on the resistor here, which is connected to the pin 7. And the pin 4 is just for a reset pin. When you ground it, it will force the timer to interrupt, which is the pin 4 is here. It force the timer will interrupt, which is this is the reset pin, which I shown just now. When I press this, let's say I pull it to the clockwise here, then press this, then this will straight away interrupt during the light LED emits process. So this is what the pin 4 does in the 555 timer, which is linked to the push button here. So let's say I'm not pressing the reset button, it will be a certain time of period. If I press the reset button in the middle of this, it will straight away turn off the LED. Pin 2 we got the 10k resistor here pull up, and pin 4 we got the 10k resistor pull up here as well. So we don't make the pin to be floated, means there is no current floated during the push button period. When you press the push button, there is no current, it's like we got float current there. And lastly, we just got the RC network to control the timer duration and for the pulse duration there. RC basically which consists of resistors and capacitors. Both will be control the timing duration for the pulse duration for the LED. So a combination of resistor and capacitor will control how long we want the LED to pulse. And here is another one I want to show is when we turn fully on the clockwise, means the light up period will be shorter, the pulse duration will be shorter. When I through the 500K is towards the anti-clockwise here, you can see there is no light emit yet until we have the center here. Then we shorter. If halfly pulse, if we do in the center here, then it will be longer period of time here. If fully anti-clockwise, then it will be shorter period. See, this is shorter period when we turn the 500K resistor fully to the anti-clockwise. Is because this is due to the resistor is fully on for the, so there is limited the current to pass through the LED here to light up. So therefore it's shorter time period for the LED to light up during the pulse duration. Okay, that's about it guys. Thanks for watching. I will make more of the electronic project for me to understand better what's going on in the circuit, as well for the audience to for my audience to understand more. Don't forget to like, share and subscribe, and see you in the next video. Bye.